So today we're going to learn about completing the square and the reasons why we complete the square. Completing the square is very useful to us because it can tell us immediately how to draw a quadratic graph accurately. The first thing it tells us is where the minimum points are, so the coordinates where y is at its lowest in regards to the curve. It can tell us where the graph crosses the x-axis and tell us where the graph crosses the y-axis. Before we do anything, we need to know the generic quadratic form, which is y equals ax squared plus bx plus c. So every quadratic will in one way or another be in this form. We also need to know the completion of the square formula, which is y over a equals x plus b over 2 times a all squared minus b over 2 times a all squared plus c over a. I'd like to stress now that we must know these off by heart from memory, and we must, at the end of completing the square, times both sides by a, because we need it to be y equals, okay? The reason it's written like this now is because it makes our calculations easier, but we must, at the end, times both sides by a. So in this example, we're going to look at y equals x squared minus 3x plus 2. So the first thing we do when trying to complete the square is to identify our ABCs. So here, a is the thing connected to x squared alone, so here a must be 1. B is the thing connected to x, and so b here must be minus 3, not plus 3, minus 3. And c is the thing which is not connected to x squared or x, so in this case it must be 2. And now we're just plugging in the numbers into our formula. So we have y over 1, because a is 1, equals x plus b is minus 3 over 2 times 1, all squared, minus 3 over 2 times 1, all squared, plus c is 2, and a is 1. Let's tidy this up. So we have y over 1 equals x minus 3 over 2 squared, minus 3 over 2 all squared is 9 over 4, plus 2. Again, final tidy up, leave the 1 under the y for now. X minus 3 over 2 all squared. We need to make the denominators the same here in order to simplify this. So we have minus 9 over 4 plus 8 over 4. So y over 1 equals x minus 3 over 2 squared minus a quarter. And finally, at the end, we're not quite finished yet, we need to get rid of this 1 under the bottom, okay? So that means we times both sides by 1 to get y equals. This is important for later when a is not 1. So we get y equals x minus 3 all squared minus a quarter. Now let's remember why we're doing this. The reason we're doing this is so we can sketch a quadratic accurately, and part of that is to find the minimum value, the x coordinates, and also the y coordinate, where they intersect those axes. So let's start with the minimum value. So here, this bracket has to equal 0 to achieve the minimum value. So the min must occur when x equals 3 over 2. This section here is our y part, so this is the lowest value that y can get at x equals 3 over 2. If we think about it logically, the reason why this bracket needs to equal 0 is because if x was anything other than 3 over 2, even if the bracket was going to be negative, anything squared gives a positive answer. So therefore you would, in a sense, reduce the negativeness of y equals minus a quarter. So in reality we're saying that if this wasn't 0, the graph is going up and therefore is not the lowest point on the curve. Okay, so that's the minimum point. Now let's find the y-intercept. The y-intercept occurs, of course, on the y-axis, which is x equals 0. So we're plugging x equals 0 into this. So 0 minus 3 over 2 squared minus a quarter. Implies y equals minus 3 over 2 all squared is 9 over 4 minus a quarter equals 8 over 4. So therefore y equals 2 at x equals 0. So our coordinate is 0 and 2. Let's rub this out and find out where the graph crosses the x-axis this time. So of course on the x-axis y equals 0. So therefore 0 equals x minus 3 over 2 all squared minus a quarter. We need to get it in the form x equals, so let's bring this minus a quarter over. So we get a quarter equals x minus 3 over 2 all squared. We then need to square root both sides, which gives us plus or minus the square root of 1 over 4 equals x minus 3 over 2. And finally, let's get rid of this minus 3 over 2. Let's bring that over to the other side. So we get x equals 3 over 2 plus or minus a square root of a quarter is a half, so plus or minus a half. So therefore x equals 3 over 2 plus a half, which is 4 over 2, which is 2. And x equals 3 over 2 minus a half, which is 2 over 2, which is 1. So therefore the x-intercepts occur at 1 and 0 and at 2 and 0. So with this information, I can now draw my graph accurately. Let's take a set of axes then, like this. The graph crosses the x-axis in 1 and 2. It crosses the y-axis at 2. It has a minimum at the coordinates 3 over 2 and minus a quarter. So let's put a point there like that, and let's label 3 over 2 minus a quarter. And now it's a case of just joining up the dots. So we have a curve that looks something like that. Okay, and that is absolutely fine for a sketch in terms of an exam question. So let's look at a harder example. Okay, so harder example now, where a is not 1, it is actually 3. So a bit quicker, y equals ax squared plus bx plus c, completing the square formula, y over a equals x plus b over 2a all squared minus b over 2a all squared plus c over a. Stress, we must know these formula, and we must know that at the end of completing the square we're going to times both sides by a to get it in the form y equals. So in this example we're looking at y equals 3x squared plus 6x minus 4. So again, a equals, b equals, c equals. A is the thing connected to x squared, so here it's 3. B is the thing connected to x, so here it is 6. C is the thing not connected to x or x squared, so c must be minus 4. We're then plugging it into the formula, so y over 3 equals x plus 6 over 2 times 3 all squared minus 6 over 2 times 3 all squared plus c is minus 4 and a is 3. Tidy this up, y over 3 equals x plus 6 over 2 times 3 is 6 over 6 is 1 squared minus 1 minus 4 over 3. Clear up again, y over 3 equals x plus 1 all squared. We need the denominators to be the same to minus these fractions together. So 1 is 3 over 3, so we have minus 7 over 3. As I said in the previous example, we need to times both sides by this a here to get it in the form y equals. So we get 3 x plus 1 all squared minus 7. We've now completed the square. So again, let's set out, let's do what we set out to do. To find the minimum point, the x-intercepts and the y-intercept. So here, to find the minimum point, this bracket must equal 0. So therefore, the min x has to be minus 1. Remember, this part alone is the y bit, So our minimum occurs at x equals minus 1 and y equals minus 7. Let's now look for our y-intercept. So remember, at the y-axis, x is always 0, so we're just plugging in x is 0 here. So we get 3 times 1 squared, which is 3, minus 7 is minus 4. So the y-intercept occurs at 0, minus 4. Let's now look for our x-intercepts, which of course occurs at y equals 0. So we get 0 equals 3 times x plus 1 all squared minus 7. We first need to get rid of this minus 7, so we'll plus 7 to both sides. 7 equals 3 times x plus 1 all squared. We always need to get rid of this thing around the brackets first before we square root, so we need to divide both sides by 3. So 7 over 3 equals x plus 1 all squared. We then need to square root, remember, both sides, which is going to give us plus or minus the square root of 7 over 3 equals x plus 1. And then finally we bring this 1 over, so we get x equals minus 1 plus or minus root 7 over 3. So our x-intercepts occur at minus 1 plus root 7 over 3, 0, and minus 1 minus square root of 7 over 3, 0. And then we can draw our curve. So, we know the graph crosses the y-axis at minus 4. We know we have a minimum of minus 1 and minus 7. So again, draw the point, label minus 1, minus 7. And we know it has x-intercepts at minus 1 minus 7 over 3 rooted and minus 1 plus 7 over 3 rooted. And then it's just a case of connecting the dots, remember, like so. And we've done it. We've completed the square and we've drawn the graph. This is the hardest example that you would ever get in an exam, okay? If you need to practice, then I suggest you use your textbook, the mixed exercise, and then you'll gain real confidence with this topic.